Welcome to 10.1. We're going to do something called combining, which is a math word for adding and subtracting, like terms. So on all of these, x is equal to 3. So x plus x plus x plus x is 3 plus 3 plus 3 plus 3, which is, I believe, 12. So now this 4x is 4 times 3, and that's also 12, because x is 3 there. Interesting, those both have the same answer. So let's see this one. 2x plus 5x, 2 times 3, plus 5 times 3. 2 times 3 is 6, 5 times 3 is 15, 6 plus 15 equals 21. 7x is 7 times 3, also 21. Those have the same answer. X plus 3x plus 4x, so we have 1x basically there, 3, plus 3 times 3, plus 4 times 3. So 3 times 3 is, right, order of operations, 3 times 3, 4 times 3, 12. And 3 plus 9 plus 12 is 24. This one is 8 times 3, also 24. So why do these have the same answer? Well, they had to have the same answer. X plus x plus x plus x actually equals 4 times x. There are 4 x's there. And so there x plus x can be written as 4x. 2x plus 5x, if you have 2 bananas plus 5 bananas, you have 7 bananas. So if you have 2 x's plus 5 x's, you have 7x. Same thing as that over there. The x is 1x, so 1x plus 3x plus 4x, 1 plus 3 is 4, plus 4 more is 8x. It's the same thing. Let's understand, if I make x a million, these problems that had the same answer will still have the same answer, right? Number one, a million plus a million plus a million plus a million is 4 million. What's 4 times a million? 4 million. Number three, if you have 2 times a million, that's 2 million, plus 5 times a million, that's 5 million. That equals 7 million, 7 times a million. And same with number 5 and 6. They would both equal 8 times a million, 8 million. And so this relationship here, what we've done here is we've added the like terms, and we'll learn that vocabulary next. So if you have 5x plus 2x plus 3x minus 7x, first of all, it's a three-way tie. You would do it left or right. That'd be 7x plus 3x, that's 10x, minus 7x equals 3x. And that's called that's called combining, and it's also called making. This is considered simpler than that. And that red expression and the one in black, 3x, have the same answer for all values of x. All right, so these are variable expressions and they contain terms. So we're going to learn a lot of vocabulary today, first lesson in a new unit. So this is an expression and there's a term, negative 7x, and plain old numbers are two terms. Our plain old numbers are terms, so there are two terms in that variable expression. It's a variable expression because there's a letter in it, a variable. Okay, and so let's do the next one. So how many terms in this one? There are 4 terms. 4x is a term, 8y is a term, z is a term, and 3 is a term. So notice what separates the term. Adding and subtracting separate terms. Notice that negative doesn't separate a term, but adding or subtracting does. There are 4 terms in that variable expression. All right, so there are many kinds of terms. There's so many, you can't name them all. So anything with x in it, we'll call an x term. Anything with a y in it, we'll call a y term. Anything with both x and y is actually different. We'll call it an xy term. And then plain old numbers, like 4 and negative 1/2, are also terms. So how many different kinds of terms in this expression? All right, so there are 3 terms, but two of them are the same kind, x. So there's 2 different, right, kinds of terms, right? Right, there's an x term and a numerical term, or a number. So how many different kinds of terms? Well, there's 1, 2, 3, 4 terms. Numbers are the same kind, so there's x's and y's are different than each other. There are 3 different kinds of terms. There are 4 total terms and 3 different kinds. The numbers are the same kind. All right, so you combine like terms, and we're going to talk about that. Now, the word combine means add and subtract, add or subtract. It does not mean multiply or divide, in other words. All right, now, so we have 5x plus 3x plus 7x. We're going to make that expression simpler by combining the like terms. So these are all the same kind of term, so we can add them up. 5x plus 3x, 8x, 8x plus 7x. And so for any value of x, x is negative 0.3 repeating, or x is 1,000,000, both of those sides will have the same answer. They are equal or equivalent. 12x minus 11x is 1x, but we're never going to write 1x in an answer. We're always going to get rid of that 1 and write x. 13y plus y is 13y plus 1y. There's a 1 in front of there, and so you add those together, you get 14 y's, right? You add another y to 13y. Now, xy terms, very different than x or y. This is negative 5 times x times y, and that's a term. So there's 2 terms there, and they're both the same type. They're xy terms. Negative 5xy plus negative 2xy is negative 7xy, because negative 5 plus negative 2 is negative 7. And for all values of x and y, this side will equal that side, and this side on the right is considered simpler. We maybe simplified it. And that's negative 7 times whatever x is times whatever y is. So what would that be? Well, there's a 1 there. What's 1 plus 2/10? It's 1 and 2/10 times y. 1y plus 2/10 y is 1 and 2/10 y. 1 plus 0.2. 1/4 y plus 3/4 y is 4/4 y, but you never write that. You'd write 1y, but you never write that. You write y. That's y. Now, order of operations matters, right? If you have a tie, you still do the one on the left first. So 7x minus 2x is 5x. 5x minus x is 4x. This equals 4x. Right? Notice if you try to do the 2x minus x first, you get a different answer, the wrong answer. So here, 8y minus 9y is negative 1y. Plus another y is 0y. But what's 0 times anything? 0. That equals 0 for all values of y. Right? Negative 1 plus positive 1. This is an example of the inverse property of addition. Now, you can only add together the same kind of terms. We call them like terms. The word like means same kind. So the variables have to be exactly the same. So 9x plus x is 10x plus y minus 5. You're done. That's all you can do. You can only combine the terms that are the same kind. 8x minus 3x is 5x. 5x plus 6y is as simple as you can make that. You cannot make it simpler. But those are equal. The second one in blue is simpler. Here, numbers are like terms, 10 minus 7. So this is 2x plus 3. You're done. That's all you can do. You can add the y terms here. 4xy, xy terms are different. So negative 6y plus 9y is positive 3y. So anytime it's positive, it'll be plus. Anytime it's negative, it'll be minus. 4xy plus 3y is the answer. That's as simple as you can make it. All right, so what does that question mark have to be to make that true? Well, we have a plus 9, so that's not it. So what x plus 7x equals 10x? Well, hopefully you can see the question mark must be a 3. So let's practice this. So 13b plus 4b plus b is 18b, right? Because there's 1 there. Order of operation. Now that commutative property there, you could have added that in any order because it's addition. On the left here, once you put subtraction in there, you're doing order of operations. 5x minus 2x, 3x. 3x minus x, 2x is the simplification. We can combine 6/10 x plus 4/10 x. You don't need the x's here, but 0.6 plus 0.4 is 1, so that's 1x. I'm going to write the 1x. 9 plus 13, those are like terms. That's positive 22, but you don't write 1x plus 22. You write x plus 22. Every time you get 1x or 1y, you just get rid of the 1. All right, 1/8 x plus 3/4 x. You have to get them like terms. So let's get them both over 8. So 1/8 x plus 6/8 x, right? You're just going to multiply that by 2. And so 1/8 x plus 6/8 x is 7/8 x. All right. Well, I ran out of room here, so this is plus 9. So it's going to be 7/8 x plus 9. That's all you can do. You're done. Here you have negative 6x, but you have no other x terms, so that goes to the answer. 1y plus another y is 2y's. 10 plus 17 is positive 27. This simplifies to negative 6x plus 2y, 2 times y, plus 27. What does the question mark have to be? All right, well, there's the equal sign. That's the key thing. We have a plus 5 on both sides. We have 8r minus r is 7r. So we have a 7r on both sides. But it's this coefficient of p. So it's 3p plus what p equals 9p. Well, it has to be 6p, right? 3p plus 6p equals 9p. Good luck with the homework.